Hello, everybody. My name is Eric Brandsburg, CTO of Heimdall Data. How many people here are very familiar with how databases actually work and how security for them works? Good. Okay. Because I'm going to scare you, hopefully. Okay. If you guys are auditors and you don't actually understand how everything works under the hood for a database, you probably have a lot of blind spots that you're not aware of that you need to be paying attention to, if only having check boxes that you know that teams need to be accounting for. How many of you are, say, internal or external auditors? Good. Okay. So disclaimer, this is for education. Obviously, not going to go through all this. You've probably seen these same words typed on every presentation that you've seen so far today. Let's talk about the learning objectives. But first, hey, I went old school. I printed my slides out and made notes. Last time I did a presentation at GRC, I didn't have this prompter that showed me what's on the screen. So I'm like, this time I'm going to be prepared. But why do we have these learning objectives? And the big point is DBAs themselves need oversight. Okay? And that is something that I think a lot of compliance teams are really ignoring. They rely on the DBAs to do the oversight of, say, how applications interact with the database. Okay? But you yourselves do not know and do not have the comprehension of what the DBAs themselves can do on what systems and what data they can access. Would you guys say that that's a fairly accurate statement? Okay, I see some people nodding their heads and such. But there is also a completely different group that I think that gets left out of the equation when doing compliance audits. And that's data scientists. The people that are actually accessing the data to do ad hoc reporting, to answer questions for executives. What data do they have access to as a baseline? And then do they have privileges in order to actually do, say, privilege escalation in order to gain access to additional data when they need it? My girlfriend, in fact, she is a data scientist that works for a national insurance agency. And she has access into PII and such, and is one of the few people in her organization that does, in order to answer just these questions. And it's on Redshift data warehouse. She's one of those people that does have access to everything. So she and I have discussed this and understand, hey, there's not a lot of accountability on what she has the access to. Okay, there's no real compliance. It's just a matter of there's trust that only a few people can do it, and you know what? They say it's needed for their jobs. But that would be considered over-scoping because she only needs it at certain times, and it should be accountable that when she needs access to that PII, then she should be able to do a request, justify it, and provide a narrow scope of access to it. But these aren't the types of things that people are really looking at right now. Okay? It's a small enough group of people. We're not talking about, say, access to data for 2,000 users going through an application like SAP or something that you need to have the roles managed within the SAP application. We're talking about a smaller group typically within most organizations, but what they can access can truly be the jewels of the kingdom. Okay? But the databases haven't really been understood by the compliance and audit teams. So I'm going to talk about those issues here. Okay, so describe how relational databases access control from and how they're different from your kind of typical application model. What the type of structural issues are with how relational databases actually implement security. And then evaluate, like, what is causing a visibility gap. I'm not going to tell you guys, like, how to solve this problem, because that's going to have to happen within the organizations, and you need to start actually simply being aware of the problems. And finally, just give you an idea of what those blind spots are so that you can start calling them out. Okay. Now, I'm just going to try to keep it at a very high level for the moment. When you look at a database audit today, you're probably getting things like what grants of roles are attributed to particular users, and that type of information. Most people, when they say, oh, well, we've got the grant list. We understand who's got access to the HR role. And that HR will have access to, say, people's home addresses, maybe birthdays, marital status. Well, that is only a part of the equation within relational databases. You have a whole bunch of other pieces to the security model, the ownership of who has access or who owns a particular object, because the ownership impacts many different layers to the security model. Session state, depending on what roles you can have transient access, where by default they may not have super user access, but they can ask for it from the database and it'll be granted with no other approvals. Context of execution, cross-boundary paths. I'm going to get into these in a bit more detail so that you kind of understand what they are, how they actually play in. But the whole point is, no tool that I know of actually looks at this entire security model and will tell you who has access to what on the database. Okay, so let's think about what the traditional model is, and I think for like modern applications, you'll have something like an application that connects to a directory server. That directory server, a group user will be a member of a group. That group will translate to a particular set of operations on the application, but then the application is now the one that's required to determine what, based on that role, they can actually have access to. But the application should ideally be able to give you an audit report who has access to what data, and you're great. On the database side, what's happened is that the databases have been built over year to year. The first version of Oracle that was released on the commercial market was in 1979. Okay, now it really didn't get the prominence that it did until the early 90s. But what's happened is that different security models and parts have been added to it year after year. They have not been removed. Typically, they are added to. So you have old modes of operation and new modes of operation that all get layered together. A very clear example of this, something that is more prominent or for some of the people that I've worked with, Redshift. Are you guys even familiar with what Redshift is? So it's a relational warehouse database that is provided by Amazon. It has two different modes of operation, or two different security layers. You have groups and you have roles. The groups are kind of the legacy model. The roles are more equivalent to some of the current behaviors in, say, Postgres. But the problem is they can both be operational at the same time. And if you ask an Amazon database specialist for Redshift, how do these two play together? I have yet to find one that knew the answer off the top of their head. Okay, even the people responsible for being experts at these databases do not know how they will interact with each other. Okay, which kind of gives you an idea of just how bad the problem is. Okay, now, I want to also be clear here. What I'm talking about isn't necessarily your normal process of setting up roles and permissions into a database. I'm talking malicious actors. I'm talking state threats that may be they've gotten access to the database and they're trying to plant something into the database that can be used to exfiltrate data at a later point in time without it necessarily being recorded or being obvious on any audit report that they have that access. Okay, and there are a lot of different ways to do this. So I was talking with one gentleman earlier, and he was like, oh, we've got everything covered, that our database, our DBAs help to ensure that the applications only have access to what they're doing. Going back to this, I'm not worried about that. If the DBAs are doing their job, they can do that part. I'm talking about who watches the watcher. Okay? So let's just talk about some of the compliance expectations that you have. And I just pulled out one thing from each of the different compliance regiments. Obviously, they kind of all layer together. Everybody knows segregation of duties, okay? Well, for segregation of duties to actually be enforced on the database and to be compliant, the DBAs should not be the ones that are controlling access to the database and adding and managing users and credentials on it. Service accounts are a whole nother beast that they end up dealing with. But I'm more talking about the human or even AI identities that are coming in as well. Yes, I said it, AI. I know you're probably hearing about a lot of different things about it, but I'll try to keep it to a minimum. SOC 2, authorized access, okay, who has access to what? Honestly, applications that use service accounts, and I'm not gonna even harp on this, but technically, that's hiding who has access to the database because it's a whole nother layer. And you can't audit it from the database who did what because it was the application that did it. The problem I have with that is that if you have 5 applications accessing a database, that means that all 5 applications become potential ways to exfiltrate data, and you won't be able to differentiate really what's going on a per user basis because it's all abstracted away. But I'm not trying to boil the ocean here and change the entire model of how databases are handled, but that is something to note. The provisioned and reviewed rights, that's generally done based on roles. Well, when you layer things together like ownership and the roles, you can have someone that doesn't have role visibility to an object, but because they owned it, they can still access it. Okay, so that just adds to the complexity. I'll get into that in a little bit more detail in a moment. And then finally, the authorized access and traceable audit logs. Well, if the database has the audit logs, could the DBA modify the audit logs or turn off the logging of the data? Okay, so the question becomes for that particular piece, for example, is there something between the users and applications and the database that has a specific log trail that the DBAs have no capability of touching? Okay, that would allow you to meet that requirement. Okay, actually going back to this, compliance is not just about checkboxes. You guys probably know all this, but a lot of other people, they look at it as a checklist of I must do this, this, and this to be compliant. The whole point for those checkboxes is to try to ensure that somebody is following best practices in order to ensure that their data is not used for non-approved purposes. Okay, you're trying to solve problems. Compliance is not the end. It is a means to the end. Okay? It is not a burden, it's actually protection. But you guys know all that. Okay? So going just briefly, I've already mentioned a bunch of this. The effective access for a database is actually resolved at runtime. It is almost impossible to look at all the individual pieces of configuration and without being an expert on each database or even each version of the database, know who is going to have access to what data on the system. 95% of the cases, it's going to be pretty easy. It's those 5% of the cases or when somebody is specifically trying to hide their access control, that is going to be the problem. Okay, it's the exceptions that you guys need to understand exist and you have to work through. Okay? Databases aren't designing their security model to be easy. They are designing it, they are adding these features because somebody made it a requirement and they shrugged their shoulders and said, okay, we're going to meet the minimum requirement in order to get that checkbox. Okay? To give you an example of this, the Mongo DB, when it was first released, it did not even have authentication or authorization at all. If you could connect to it, it was considered you have access to all the data on it. Okay? The Redis database, a lot of times used for caching and such, but it's expanded out in use by default, does not do authentication either. You can turn it on, but it's not on by default. Okay? These are the types of things you should be checking to say, okay, are all these databases actually enabled to have security? Are they doing TLS? A lot of the databases, even though they may support TLS, they will not actually, the drivers will not enforce verifying the TLS certificate without actually having that option turned on. They may give a warning that this certificate was not validated, but they won't actually enforce. So you need to look at those options within the driver to ensure that that is accounted for. I didn't even include that on the slide, but yeah. Okay, so these features are tacked on over the time, answering the question, can we authenticate against a user? Yes. Okay, but it's usually not easy to verify everything that they're doing. They didn't go that far. They're like, can you do it? If so, they got the checkbox and they moved on. Okay, so if you're getting static reports on what is on the system, it typically will say, okay, this user has this role. Does it say what roles that role has? Because they can do nested roles. All these different things that are in a static report, they don't resolve to runtime. It's more a matter of, here's what's configured. What that actually means, that can be hard to deduce. Okay, getting down into like object ownership. The object owner connects or owns a particular object in a database. It's normally a logical database. Basically, kind of think of it as kind of partitions. This is one database. Within that, there's something called a schema. Under the schema, typically tables. Well, the schema can be owned by a user, which can implicitly grant access to things under it. A table can be owned by a user, granting implicit access to that table. And all these things get layered together, and they're not even part of the roles. Okay. Now, one of the things that many organizations will try to do in order to solve some of these problems is to try to implement a system with just-in-time access into the database, where an ephemeral user is created on the database. Then that user will be allowed to do certain things and roles will be attached as needed to that just in time. In fact, my product, which I'm not going to make this a product pitch, does this as well. But they haven't, most of these tools have not accounted for things that happen during the session while the user is actually in the system. A user could create a new table, put some data in, maybe copying it out of another table. If they're super user at that point, they could literally hand that table off to a third user or another user, log out of the system, and that may be a less privileged version of the same user. And they'll have access to that data after their ephemeral session is gone. Or they could create this table, and it creates a conflict resolution state. When that ephemeral user is supposed to be removed, what happens to the object that they created within the database? Okay, now, in some systems, if you try to remove a user that has objects that are owned by the user, it will fail unless you do a forced override, in which case it may delete the object owned by that ephemeral user. Okay, but this is something that each database actually handles in a different way. Okay, so these tools that aren't accounting for object ownership on session termination may end up leaving state around that can impact the security of the system as a whole. Okay. Now, recursive roles. I touched on this a little bit. How many of you work with, say, Active Directory a lot and group memberships and such? I expect that probably quite a few are, even if you're not raising your hands. How many of you really get irritated that Active Directory does nested groups and how complex those nested groups can be in order to figure out who actually has access to what? Okay, I'm getting a bunch of other hands. The issue here is that you see the problem at the Active Directory level. Okay, one group under another group can hide if an individual actually has access to certain data throughout the organization. Many directory providers that have come on the scene after Active Directory have actually removed the concept of nested groups because it causes so many problems. Okay, I think Jump Cloud, maybe Okta, I'm not sure if either one of them provide the concept of nested groups in order to avoid this very issue. Databases have exactly the same problem because you can have nested roles within the database itself. You can assign one role to another. If one of those provides over-provisioned access, then it may not be visible at the top level. Okay, very hard to deal with. So knowing, just as an auditor, you can look for the existence of nested roles and flag that as a potential concern. Okay, just knowing that they are there gives you a checkbox to spot and possibly trigger more complex auditing on. Okay, all databases just keep adding to the complexity. They're not reducing it. Okay, session state. One very particular example of this. If you have a user on Postgres, very commonly used database, and they have a role attached to their user that has super user privilege, then by default, when they log in, they will not be considered super user. If they try to do something outside of their normal privileges, they still won't gain access. All they have to do is call the set role super user command. Bam, they're now super user. Okay? It's not apparent on casual testing that they actually have this, but they do. And I've actually talked with people who thought that super user must be assigned only to the user themselves for it to actually be active. These are DBAs that have been working with Postgres for years. They didn't realize that the set role command will give it to them anyway. So even experts on particular databases are getting things wrong. Okay. Execution context. There's a very good reason for why this exists. But I will call out a very specific example, a stored procedure. And for those of you that aren't that familiar with a database, what it is a stored procedure is a set of commands, basically a little program that operates on data within the database. And you may have a stored procedure that needs access to, say, PII to correlate different tables on a particular user based on, say, address. To see, let's say, are there other users that have the same address as this one, say for medical purposes. But that PII should not be given to a user, and it's just going to give the list of users that may be at the same address as the first one, but not say what the address actually is. Well, a stored procedure can be set to execute as a particular user or role outside of the context of the person calling the stored procedure. So now you've got two different pieces here, what they can access themselves, and then can they access this stored procedure that can then access other data. It can get very complicated. Okay, can you guys see why this is an audit nightmare? Okay, so there's very legitimate uses for a stored procedure like this. But you can also create a stored procedure, let's say your super user, that can be told as data input, take another query and execute that query as the security definer. Dynamic SQL generation is effectively what's happening here. Or there's a bug in the stored procedure that can be used to effectively do a SQL injection attack that will then give access to other data. So knowing that stored procedures are on the system that are running this way, and checksumming those stored procedures to ensure that they're not being changed would be part of an audit cycle. Okay? Because this is a fundamental and integral part of who has access to what. You may not go so far as to say what exactly that stored procedure is doing. The DBAs could audit it and have approvals sign off saying, no, this is correct. But you as auditors should know if it changes. Make sense? Okay. Identity substitution. Now this one's a little bit tricky. On multiple databases, for whatever reason, I think that this is one of these legacy things that they didn't think through. They have a concept of a proxy user. You log in as one user using one user's credentials. But once you're in the system, you're actually executing as another user. Okay? And those proxy users don't show up on the normal user list because it's a different type of construct. So you have to specifically look for proxy users to know if they exist. Another checkbox item, do proxy users exist on the system? And if so, why are they there? Are they actually needed? Okay. They're effectively ghosts in the system unless you look for them. Okay. Cross-boundary access. Within a database system, there is something called, every database has one or more constructs like this, called a foreign data wrapper or a foreign table. What they do is they actually create an apparent logical construct on the database. It looks like a table, but it's actually calling data from another database outside of the system. And in the process, the database is using a credential that's programmed in the system to make that call as a different user. Effectively, it's a service account. On Postgres, if foreign data wrappers are being used, guess how that password is stored? Plain text. Okay, if you have super user access, you'll be able to read that password with no problem. Okay, meaning that you may have just given access to that other database to the super user. Now he can log in directly and access that data himself, or use the foreign data wrapper to access that data and hide it as well. Interesting point, the foreign data wrapper could point back to the same database, hiding who's actually accessing the data on that same database in a loopback manner. Okay, so all these things coming together, it shows databases aren't designed to be secure. I read over a review where like Oracle said that, oh, we meet all these compliance targets if this, and this are met. Guess what? If the DBA has super user access, he can violate those constraints just by adding in something that's not part of the supported configuration. Okay, the DBAs end up having the keys to the kingdom. You need to be able to audit to ensure that they did not change what the compliant configuration was. And if they did, what changed? Okay, so configurations do change. Okay, drift needs to be reviewed. Why did something change? Okay, you need to treat the drift as a signal, and you may need to be able to see it. I know a lot of audits end up being annual and such. My personal take is that any sort of drift on systems like this that are sensitive enough, there should be a continuous process to understand why these changes are being made. And if they're made outside of approval, well, why? And make sure that the process to approve them before the change happens goes into place. You need to understand the role memberships. You need to look at privileges on the existing users and roles. You need to look at ownership of the tables. Everything, the foreign data wrappers, all these need to be flagged and any changes validated. Okay. But even if you look at all these different things, you need to look at the runtime interaction. Tools need to be able to look at the whole picture and understand, because this changed here, it impacted the ability of something else to access through it. Okay? You need to understand the entire end result of the change, not just one individual item. But obviously, starting with the individual items is where you want to begin. Okay. Another point, and I had pointed out before, like the stored procedures in dynamic SQL. That results in non-deterministic security on the database. It's based on how it executed at runtime. And that's particularly scary if you don't have basically change controls over any construct in the database that could be changed to impact the security of the system. Just going to skip this one for the moment. SOD obviously is pretty important, but effectively you could have things changed where individual people with segregation of duty made a decision one part or another, but the net result is that change impacted in a way that was not expected. And while segregation of duties can be said, yes, we're adhered to it, it may still result in vulnerabilities. Okay, obviously you need to monitor all the pieces that affect the control model and then boil them down. Okay, so what do you need as auditors? Okay, you need to create an evidence pipeline for the configuration of the database, who owns what, the execution model of every piece. You need to understand that everything is context aware. You need a process for gaining that evidence and evaluating it for change, reviewing it, and then testing that everything stays within what you expect it to be. Okay, obviously continuous evidence gathering is, and continuous assurance is ideal. The closer to a continuance you can get, the better. Okay, starting off, obviously, a lot of organizations that have not built up, they've got to start from somewhere. Get even the manual or ad hoc, just at least getting a snapshot. Start thinking about what is there, learning, working with the DBAs to say, no, we're not using proxy users. Okay, let's verify you're not. Periodic extraction, continuous monitoring. Obviously, tools need to be built that support that. Hint, hint, there's a reason why I'm here. Okay, practical workflow for evaluating effective access. Okay, start with the most sensitive data. Find the databases that are key, that need the most protection, and understand what's going on with those first. Okay, establish identity context. Who has access to those systems? Then boil down what in those systems they have access to. I'll evaluate all the execution paths, our stored procedures, executing as other users. Let's flag those just to make sure that we've got those under control. And evaluate all the changes over time. Okay, if you cannot do this, then you cannot attest that everything is secure at any given point in time. Okay, and even doing it at one point in time is a difficult task. Okay, similar idea, identify the information that's high value, identify the high risks, and identify where those two converge. Okay, so closing the data blind spot, you need to validate effective access, not just the reported individual constructs. You need to look at it in sum total and how they come together. You need to account for this runtime behavior, and you've got to reassess when things change. Now, this is the last formal content slide, but I'm going to talk about one last piece. AI. Okay, I'm going to give you an example of how things can get really scary really quick. Let's consider you're an auditor for an organization that is using, say, Kerberos authentication within their system, their environment, to control access to the databases. Well, Kerberos, when somebody logs in as them, they can now execute software that has access to what they have access to. They install OpenClaw onto their system. OpenClaw will now execute as them. Okay, meaning that it now has access and looks like that user. Okay, if you have any of these structural vulnerabilities that are in the system that you had not accounted for, AI can be far more creative sometimes in finding a way to leverage that to access the data than the user themselves ever knew about. Okay? It could use those foreign data wrappers that happen to be callable by that user in order to explore the data on other systems as yet another user. Okay? So if you're interested in our solution for that problem, you can come on by our booth, okay? And we can talk about it more. I'll thank you, everybody. I'll love to hear any feedback. Let's see if there are any questions in here. I'm not seeing any. Oh, okay. I guess everything was under pending. Okay. Can these rules, lessons for relational databases apply to cloud databases as well? Yes. Okay. Relational databases, whether they're in the cloud or on-prem, generally operate in the same way. And yeah, so they apply to the cloud as well. Is immutable log monitoring of database activity a good solution for identifying data exfiltration from databases? You can use the logs, but there's some tricks here, okay? Often the logs will account for what is executed on the wire. Well, you can use things like the dynamic SQL creation to create SQL that executes on the database that will say take social security numbers, change their format to look like they're, say, UUIDs, which are generally not considered sensitive, and then actually extract them. And on the wire, it doesn't look like anything necessarily malicious is called, just that there was some dynamic SQL generation happening. So depending on where the logs are, you may or may not see it. It is my opinion that the key important point is to ensure that every user has exact access to the data that they need, and that you can log what they are doing so that if something is suspected, you can look for something suspicious. Dynamic SQL generation will look suspicious, but you won't necessarily know what it did until you actually go through it, execute it, and figure it out yourself. It can be very hard to do. All retention requirements related to the database blind spots. That's generally going to be about like what evidence is being gathered, just like any other system. The key is you have to have evidence before you even need to worry about retention. Okay, the problem is most organizations don't even have evidence to retain. Not yet. Okay, if an auditor isn't a technical expert in relation to databases and the DBA doesn't know at all, what kind of questions can the auditor ask to uncover these types of specific and detailed issues? Again, not trying to make this a product pitch, but our company has been working on software to basically give a standardized report of what is important on the database that you should be paying attention to. That can call out things like these proxy users, foreign data wrappers. It generates checksums of these items such that you as an auditor don't have to understand everything. You just need to understand what's changed and bring it to the attention of the DBA and the team that in theory should know why these things are there. You don't have to be the expert. You just have to have something to go from. And that's what we're trying to give you. If DBA services are outsourced, what kind of third-party oversight and due diligence is needed to make sure that DBA access is properly controlled? I keep kind of going down the path of trying not to make it a vendor pitch, but the key is you need to have those tools available to you, whether they're from my company or someone else. You now know that these are things you need to be paying attention to, and you can look for the appropriate people or tools that can help you solve these problems. As an auditor, if management gives me an IAM or DB grant report for a user access review, what specific procedures would you recommend to establish that the population is complete for effective access before I start sampling? That's going to be hard to say without actually knowing exactly what database you're on. Everyone is a little bit different. And that's why we, as part of our solution, have tried to normalize the access control report to make it a little bit easier for you guys to go through and look at these things. Okay, how do you solve for the risk of DBAs disabling or modifying the logs? The answer is you have a logging mechanism outside of the database between where the DBA can access it, basically a DMZ. As it crosses the DMZ, it logs, and that DMZ logging mechanism should be controlled by someone other than the DBA. Okay, and I think I basically hit time. And if there are no other questions, thank you, everybody.